Check, check. It's okay, no? Okay, let's start. So this is a presentation which I actually gave earlier, or rather end of last year at the PyCon in Delhi. It's slightly rehashed. Right, so it's maybe a little different from the other things because this generally conferences, Python conferences, modern conferences generally they're very web centric. This is not like that. So this is a bit about me. Hamon Technologies, that's my company. People Academy was a training firm I co-founded with Anand. We're one of the sponsors here. I also mentor students via this. Some of you might know, some of the students here might know. And I've been involved with PyCon India since the first one. That's my Twitter handle, so if you want the slides, I just tweeted them out. You can get them from there. This presentation is slightly, it's a little outdated because I've been using CFFI since after I did that initial presentation also. A lot of things have changed about my ideas about using it. I'm still a fan, but like the way I've used it has slightly changed, although the slides have not, so there's some anachronism there. But yeah, I think it'll still be beneficial if you're doing this kind of work. Okay. So let's start. Now the first thing is, I mean, we're all Python programmers, right? We're all this thing, but the whole world doesn't use Python. Okay, we have to rely on languages and data and things like that written in other languages other than Python. All right. The most common example, I guess, these days would be like who has done web scraping over here, or consuming some kind of API, that web-based thing. So it's very likely that the program, I mean the thing which generated the data which you're consuming is written in PHP or Rails or something else. All right, well, although you are consuming it using Python. Okay, so in a very general sense, this is sort of two different languages interacting. So you have you do a REST call, you get something, you post something. The actual program that's running might be written in PHP or Rails or something, whereas your program here is written in Python. Okay. This is nice, but the problem is there's a lot of latency, like a network socket gets established, HTTP request goes, comes back, you get the data back, etc. There's also issues with serialization. You have to send it in a format which actually makes sense across the wire, you have to deserialize it, things like that. So it's slow, but it's very flexible. These two things don't have to be on the same computer. They don't even have to be on the same network. Right? So it's very flexible. This is very commonly done. Another way is IPC. IPC is like inter-process communication. So if you have two processes that are on the same computer, they might be running, they might be written in different languages, but you can communicate across them using maybe, I don't know, like some primitive like a socket or shared memory or something like that, or something like using some kind of broker in between. You push messages to someone, this guy fetches messages from there, does work, and sends the results back to you. You can also do this with some more primitive things like signals, but then there's like one-shot kinds of things. So that's also there. A little more closer is if you have common runtimes. Like for example, if you have Java and Clojure, like after the language they finally run on the JVM, right? So at that level they're sort of the same, right? So if you push down and you're running a language on a VM that is actually shared between two different languages, you can interact at that level. All right? And even below that is what we call FFI, because finally there's physically one maybe processor running your code inside your computer. All right? So if you have to finally, you have some code, you can make the processor run other code and come back to you. Right? Finally, it's like somehow it should be theoretically possible. That's true FFI. Okay, FFI is foreign function interface. It's like a way of calling functions written in another language. Okay, I have a little rant here, all right, which is since it's something which I feel strongly about. I mean, I've been coding in Python since 2001, but I like to think that I'm not a fanboy. Okay, I mean, Python is nice. It's useful. It's very very efficient. It gets my work done very quickly. I enjoy it a lot, but it's not the end of the world, right? There are other languages that do other things in different ways. Some of them are interesting, some of them are not, some of them are good, bad, better, whatever. All right, and the nice thing is that there's a difference between these language warriors, like people who are like, I'm a Pythonist, or I'm a Rubyist, or I'm a what do they call it, Rustacean, these kinds of things, versus the languages themselves. A Python program will not have any problem if it reads from a Ruby REST service. All right, it will work. But a Python programmer will have a problem if he reads from a Ruby REST service. Okay. So the programmers are like, you see the stuck-up people. The languages themselves are cool. It's like, yeah, okay, chalo, take it. I don't have a problem. If I can parse it, I'm fine. I don't really care where it came from. But the programmer, like, dig in and try to find out, like, this was implemented in Ruby, so no, I can't use this, or something like that. So FFI sort of is like, peacemaker. It's like, like chill. I mean, it's okay. I mean, you get your work done. That's enough. That's what we need. This talk specifically is based on a library which I'm working on. I claim to be working on it, but it's been stagnant for a while now. Last commit was like the end of December or so. It's basically has anyone used that thing? I think I mentioned it here. PSUtils. Anyone use PSUtils? It's a popular Python library. It's very nice. It gets you information about the system you're running on in a cross-platform fashion. So now, like, network packets, or like, CPU usage, things like that. Okay. So this library which I've been working on called cpslib, it's like a C port of that. Well, why a C port? That's a bit of history. I wanted to get into Rust development. So I found a bug open on the Rust tracker, which was like somebody wanted to port PSUtils to Rust. So I thought, okay, I'll port it to C and then I'll wrap it using the Rust FFI so that it'll be available in Rust. I started working on it and it was going very well, but then they closed the PR saying that they don't need it or something. So I've stuck with an orphan library, but it still does what it does pretty decently, so I've decided to keep maintaining it. And the thing is, the library itself is written in C, but the tests are written in Python. Okay, so I consider one of Python's killer tools, why should you use Python? Because py.test. Okay, I'm a big fan of the library, and I'd like to use it for all my work. So I try to wrap the library in Python and then use py.test to actually run the test. That's how this talk came about. That's the history of it. So this is basically what it does. I'll give you a small example. So this is like, people who are not familiar with C, just bear with me a little. All right. It's basically this. This is a function, CPU count, which is a function that actually gets you the number of CPUs. You call CPU count. You say false, it'll give you the number of physical CPUs. If you say true, it'll give you the number of virtual CPUs. And it'll give you how many there are. So you can print it out. You compile it like this using GCC with all of this. You link the pslib library. You get a program called CPU count. You run it, and you'll get the number of CPUs. So this is how you use it. This is like a simple call from within the thing. Now, the thing is, I'm trying to port PSUtils, right? So PSUtils, I have PSUtils to refer against. So it's annoying to have to check each function one by one. So it's nice to have to do it, be able to do it in an automated way. I claim to be an automation person, and if I have to do all this manually, I can't go to my clients and say that, so I have to do this. So there are multiple ways of doing this. The crudest way, the oldest way, I guess, would be to manually write a C extension. How many people here have written Python C extensions manually by hand? Did you enjoy it? It's no fun at all, right? I mean, there's hazard details you have to be worried about and things like that, and it's very hard to get right. And I mean, I get you can do it, but I mean, it's not much fun. So I decided to look at this because I think there was a post by someone talking about using CFFI for something. I don't remember. I mean, this thing was in my head somehow, so I decided to look at it. But just to give you a comparison, there's a standard library module called C-types. How many people have used C-types? Yeah, so C-types is like a library it's like a CFFI, it's like an FFI library that's part of the Python standard library. You can do something like this. You can say import C-types, and you say ctypes.cdll. You give the name of your shared object, your SO file, that's your shared library. You can call functions inside that in this fashion. Okay. So when I say cdll.cpu count this, I'm actually calling the CPU count implemented in C. Okay. It runs in C and comes back to Python. Okay. And Python doesn't complain. versus the Python programmer who will complain because it's written in C, as I mentioned. So it will work like this. This works because the types are very simple. I mean, you get back a number and you send in a boolean. If there's a little bit more, you might have to do a little bit. You might have to do a little more work. And for that, I have an example which is sort of infamous. This was like in the news at the time of the PyCon in Delhi. Anyone remember the leftpad business with JavaScript? Yeah, so leftpad.io, leftpad. The kernel, Linux kernel, leftpad. The kernel extension, the kernel module for leftpad, etc. So leftpad is a function. Basically, it pads a string to so many spaces. So I wrote that in C. Why? Because leftpad is an important, cornerstone of internet infrastructure. So it has to be fast. All right. So we write it in C. You compile it into a lib-leftpad.so, and I want to use this function from within Python. Okay. This takes 3 arguments. It takes the string. It takes the the length of the string and how much you want to pad it by. Okay. And it returns a padded string. All right. So if you want to wrap this using C types, you have to do it like this. It's kind of hairy because you import everything from C types. I don't recommend that you do this, but it keeps my slides compact. So you load up the library like that. Then you have to sort of, the leftpad string function, you have to say arg types are, there's a car p, there's a c size t, another c size t, and the response type is, c car p. You have to manually specify all this. And then you can actually call it. You can say leftpad string, you can call it with ip, the length of ip, and, pad to 20, and you get it back, and it prints it out. Okay, so this is padded now. Okay. So, but the thing is, you see, look at how much extra code you have to write, right? All this extra code you have to write, and this becomes even more complicated when you have to pass a structure or when you have to pass anything more elaborate. So this thing it gets verbose very quickly. Okay. And Python is wanted for, being compact and all that, so verbosity is not a good thing. So, but the thing is, C types is part of the standard library, and while there are many nice modules out there for doing various things, if it's the standard library, then you don't need virtually env, pip install, you don't need any of those things. So you install Python and it'll work. Okay, I mean, when you try to, we do a lot of IoT-ish kind of work with small devices that have Python running here and there and all that, and to get all this stuff installed with the right versions, sometimes you need a C compiler because there'll be C extensions. Without all that, if you just install Python and it works, it's fine. So I use URL lib instead of requests. Why? Because I just don't want to do the trouble of installing requests every time I try to create an image. And it's just one small piece of code. So I prefer, if I can use a standard library, I'd use that. And this thing, it works on PyPy, CPython, even Jython. Like if you run this program in Jython, the JVM will actually use, I guess, JNI or something to call the C function and give you the value back. Okay, so which is really nice. That's why I use the %s thing instead of the curly brace thing, because Jython, it doesn't work otherwise. Okay. Then why CFFI? Well, CFFI has some advantages. That's what we're going to talk about. First of all, none of the C size T, all these extra types which you have to specify, you don't have to do all that. Okay, it does that for you. I'll show you how. It can work at the API or ABI level. What does that mean? Basically, you see the way we used it here? Yeah. We don't use a C compiler here. We just directly sort of load up the SO file and just call functions from within that. Okay. This is using it at an ABI level. Okay, at a binary level, which means we basically translate all these things which we pass, this IP, len IP and 20, we translate it to corresponding C types, write it into the stack in the appropriate places, transfer control, make it do what it's done. When we get it back, we come back inside Python. Okay. The problem is that's tricky to do because you have calling conventions on different platforms, different compilers, different forms of the library, things like that. It might crash. Once you get into the CFFI world, your Python interpreter can segfault. Okay, it might not just raise an exception which you can catch. It'll just segfault and crash. Okay, so those kinds of things can happen. CFFI, the advantage is it can work at the API level also. I'll show you what that means, it involves an extra step, but it becomes more robust. Okay. And I guess it's a little faster also. I don't know. I'm just pulling that out of thin air, but yeah. So how will you use it? Let's use the ABI thing first. You can see what it looks like over here. I say import CFFI. CFFI, you have to pip install it. It's not part of the standard library. You have to pip install it separately. I think this was created by the PyPy people. Okay, and like all the other things they've done, this is also really cool, really awesome, and well, I guess magical in some sense. What it does is you say cdef and you cut paste your function prototype there. Okay, so you can just load up your header file and just cut paste the whole thing inside there. You don't have to type all this stuff manually. It'll actually parse that and find out the function signatures for you. Okay, so if you have a manual page and you have like the prototype in the manual page, like if you take any typical C function, like I don't know, get pw or something, you'll get something like this in the man page. You can cut paste this directly into CFFI and it'll actually create the wrapper for you. You don't have to figure out all the types and the corresponding thing and C char P, C char T and all that. You do that, you open the thing over here, just like the other one, DL open, lib left pad, not this thing, and you do the same thing as we did. This will work exactly the same way as we did with the other thing. Okay, so this is an advantage. You can already see that we don't need the C char T, C char P, etc. For complicated structures and all that, it becomes very convenient. The problem with ABI is, as I mentioned, you have to guess like the memory layout and where to put these things in the stack and all that. So it might crash, it might behave unpredictably. Which members of the structure to put first, which members to put last, packing, things like that. Usually the guy who does this for you is your C compiler. Okay. So what you can do is, instead of using ABI, you can use API, which is, you do the same thing. You say FFI, you say FFI set source. You say I want to create a PyLeftPad using leftpad, the SO file. Give the library dirs and all that. You put your prototypes over here and you say ffi.compile. If you do this, you will get a pyleftpad.so. This will invoke your C compiler and actually compile and pyleftpad.so. Okay. A native C extension. So what does this mean? Yeah, you don't have to write your C extensions manually anymore. All right. So if anyone who's gone through the pain of debugging one of those things, this is like a godsend. You have a C library, you just say I want these things exposed out, and it will generate the C code for you. It will compile it into an SO file. You can load it up, and the nice thing is like the SO, if you're compiling it depending on which compiler you are using, depending on which flavor of Python you're using, it can actually generate the SO file which PyPy can import also. So if you write your wrappers you have a super fast C library to do something. You write your wrappers using CFFI, it will work on PyPy and Python, CPython. Okay, you'll have one extra compilation, but it will work. The downside, well not downside, it's just a nature of things, is that it exposes like function by function. So usually like you've noticed, right, if you use PS utils, you have things like you'll have a process class which has like inside it send signal, get this, get that, etc. You won't have that kind of thing over. It will expose function by function. So you will have to write a higher level wrapper on top of this. But that's okay, that's Python anyway. So now once you get this, you can import pyleftpad. This will actually load the pyleftpad.so. You do all this. It has a .lib inside which you will have the actual thing, and then you can say, you get the thing back. It will have a .ffi, you can convert the thing back into a string and you'll get this. Okay. And it will print the same thing as we did. So here's some quick timing numbers. Like I don't know how representative these are, as we all know, all benchmarks are wrong, so, but this is just some numbers. I can sort of understand why this is faster, because you have compiled code where the type translation does not have to take place on each call. So that's there. But apart from that, I don't know. API is fast, and it doesn't cost much to do it. So that's probably the right way to go anyway. So what do I do? If you want to now we have this thing generated, right? You have the pyleftpad generated. I can do it like this, and I can write a test for it like this. Test leftpad, say input is just Python, and you say leftpad this, IPR just this, and you can run this using py.test, just like a regular thing. So this is actually a C library which has been wrapped by CFFI to create a Python extension which I can import, and then I can test it just like I would any Python module. Okay. The whole of the py.test ecosystem comes. You have your -x, -pdb, minus S, the markers, all that stuff, the parallelization, everything you can use. Just use it like that. My own library, it has a lot of these things, what you call, lot of these functions like CPU count, disk free space, network input, network output, blah, blah, all these things. So what we did was we just opened up the header file, you remove everything with hash include, you put all those things as cdef. Okay. You just run this, it exposes all the functions inside that C file as Python callables. So this actually allows me to get cpslib.so, pycpslib.so, which I can import from within my program and directly use it. So you use it something like this. You say import psutil, this is my reference. PyCPSlib is the one which I generated. So from PyCSlib import lib, I call it p. Then I say p.cpu count equals the psutil CPU count. P.cpu count this equal to the p, which false. So this will actually, this is actually a test for this. All right. So I can compare like, and the nice thing is like now I have a list of APIs which I have implemented, I know how they work. The test suite can be run on multiple platforms. I can test it on Linux, well, we have only Linux and Mac OS support right now. We haven't done the Windows thing yet. So yeah, so you can do it like that, it's very useful. The other thing which I sort of cooked up as part of this is to actually measure the test coverage. Have you used coverage.py? Yeah, so coverage.py, if you're using it in py.test and all that, it's very nice, right? You just say pytest minus minus cov equal to the name of the module and you'll get your coverage. You'll get a nice, if you say minus minus report HTML, you get it as a web page also. It's very nice. In C, it's a little harder. First what you do is you compile your program with all this. You say fprofile args, ftest coverage. This will produce a GCNO file as part of the compilation. Then you run it. It will produce a GCDA file which contains the actual data. Then you run gcov leftpad, which will give you human readable output. That will give you a .gcov file which will actually contain the coverage. Okay. So if you want to run coverage on C programs, this is what you have to do, with gcov at least. So I've written a small pytest gcov that automates this for you. All right. Although it's got some issues with writing the data, so there's some dirty tricks I had to do to get it to work, but it works for me. So I can actually measure how much of the program is covered, so that works. The basic thing works. It's on GitHub, so if you want, you can look at it also. So this is basically what I have to say. This is all. There's not much more. The way we've done it, and so this is my contact information. I'd recommend this. I'm doing another talk sometime later, maybe next week at a different meetup on just low-level file formats and all that. I think, especially of late, because of how easy it is to get something really cool out the door, people sort of miss out on the lower-level details of what goes on under the hood. Right, and especially if you're students, I encourage you to do that because you get an idea of what's going on beneath the the interpreter and stuff like that. Okay, and I'll leave you with a quote. Okay, so it should sort of inspire you to look a little below Python and go a little bit deeper into what's going on. Yeah, so that's the talk. If you have any questions, I'm open to it. I think Kushal recently had some wrapping Rust libraries. That's Kushal. I saw a post or something about wrapping Rust libraries using CFFI and calling them. Any questions? Anything? Yeah.
So yeah, one sec. In C, the library, if there is a segmentation fault, the total process gets killed. So, is there any way to handle in Python like only the?
No, not really. I mean, it's like it's out of your control, right? Once you go inside C, and then you're in the C world. You don't get neat exceptions and all. No. If it crashes, it crashes.
I mean, what my thing like you may have different threads in the Python, and one thread is only doing that C library, and in fact, because of your faulty library, your total process Python itself.
I haven't done that. I've sort of like a project which we're doing now is like to make a headless RTC library, And for that we are actually calling out to a C module, shared library, but like we do it before we do the threading. So when it crashes, it crashes. I don't know about a single thread crashing while everything else is running. I haven't done that. That's probably something I should check out. I don't know exactly. But so it's kind of hard to debug it directly. So if you get your Python debugging symbols and everything, you can call GDB with the interpreter straight and then do it. But it's often easier to just, you write a small stub program to call that function directly in C, compile it as a single C thing, and then use GDB on that. Just replicate the outputs. That's usually easier. From within Python, you could set a breakpoint for that specific function. So let the Python thing run. Then finally, when that function comes, you get inside, then you can inspect your stuff with GDB and figure out what's going on. That's possible. Yeah.
Hi. So I've been using C types a lot recently because mainly what I use it for is signal processing and stuff.
Okay.
When native Python is not fast enough to do something that I want, I go to C.
So you want to go to C?
Yeah. So I was wondering, what are the other use cases where you want to go to, like C level other than that?
So I think speed is one thing. Bypassing the GIL is one thing. Once you go in there, you can parallelize as you want. This kind of thing where you want to, my use case is specifically just for testing. I don't think this will be the official Python bindings for it, but my use case is just for testing. Those are the three things I can think of. I don't know of anything else, really. Performance mostly, yeah, that's why most people go down to it. And sometimes you want to, twiddle with the hardware. You want to do low-level stuff, but you want to script it from this thing. So we had a project which we did some time ago, which was to actually write a test framework for a camera. And that time CFFI was not released at the time, so we used a raw C extension, but it would be very nice. Like the camera would be sitting here. You could say import camera, and you can say C equal to camera.camera. You'll get a software interface to the camera. Then you can say camera.init, the light would come on. And you can write a test, which would actually test parts of the camera. And you can automate a few lights and test past. You can do stuff like that. So if you want to interface with the hardware at that level.
Hi, a question about what is this? Does this support C++ based libraries?
No.
Okay.
I'm sorry, no. So if you have a class with the rest of it, templates and inheritance polymorphism, no. This uses a library I think called PyCparser by Eli, the eli.thegreenpeace.net, I think.
Okay.
A lot of people read his blogs are really good. So he's written something called PyCparser, which is like a C parser written in Python. That's what it uses to actually parse those CDEF things. That doesn't support C++, so no C++.
Okay, and just a added question is I saw that there is an FFI.compile that you did, which probably generated a DLL.
The SO, yeah.
Yeah. So is that just like a stub DLL, or could I even switch on some things like optimization flags?
You can specify the flags you want to, like this thing. Where is that? Yeah, so when you say set source, I think it's in set source. You can specify various arguments to your C compiler over here. So you can say -O, -G, all those kinds of things. Also, I think it honors C flags, so
okay.
that also works. Yeah.
Any more questions?
So if anybody's interested in this, I would have liked to stay for the sprints, but I have to go. But if anybody's interested in getting your hands dirty with C and seg faults and crashes and things, then let me know. I'm looking for contributors for this. So. All right, that's it. Thank you.